Everybody, back with the video. I got this in the mail and I've been wanting it, but I wanted to show that it's not really packaged very well inside the box. It's kind of flying around there, but I did want to open it up and show you guys what I got here. Can you see this okay? Yeah, just a little open the box thing, because I love new tools. And this is what I got. I guess it wasn't packed that bad. It was just, it did move around there a little bit. I got a BK Precision. You can't really see it, I guess. 864. Like that. So yeah, BK Precision 864. And I am going to open this up and see what it looks like. Alright, here it is, a better view of it here. The reason I got this is I actually downloaded the software in evaluation mode, and I really thought it was going to be one of the better programmers. It is a little bit more expensive than some of the ones that I've reviewed so far, so I keep kind of trading up, I guess. But let's see what's in here. Looks like it has a power supply, 15 volts. Does it say what the how many amps are on it? Only 1 amp, 15 volts, 1 amp. But I think this is what it came with initially, because it has a special little connector there, little DIN connector. I wasn't even sure if this was going to come with it, but what I believe this is a self-test adapter, so you can actually do self-tests on the programmer. I like that about the Advent system. The EMP30s didn't have it, but I do like the fact that you don't actually, on the other ones you didn't need an adapter, but excuse me, on this one you did. A parallel cable, some discs. I don't know what is that? I guess that's just whatever. Oh, a cover for this. Software accessories. You can download the code still, I think, from the BK Precision website. And this is it. It is parallel port only. It's not very big. This is in great shape, actually. Wow. I didn't think it was going to be in this good of shape. Really nice. 48 pins. Yeah, I'm pretty excited. Obviously, external power supply, just like the EMP20, but you do not need any special modules or adapters. I don't know. And then this little cover here is just to cover this when it's not in use, which is also nice. I don't have one of those for the other ones, and you would think that they would get dust and dirt and stuff like that. So that's kind of nice to keep that on there. Keep your favorite programmer dust free is what it says on there. Very cool. And looks like this was printed out in a manual format. So I'm not going to go through all these pages, but I'm going to put this manual in a binder real quick since it's already set up like that. So I'll do that off camera and come back, and we will maybe do a quick review of it programming some chips. Alright, so I have the power supply plugged in, and it is 15 volts. And so let me just want to test it real quick if I can. That will stay on there. And we'll connect here. No, you can't. My hand's in the way. Dang it. Alright. Yeah, we're getting 15 volts DC. So we're good, and it's the same voltage on all the pins. I don't know why they have so many pins, but whatever. I double checked that off camera. I just wanted to show you that I checked it. Just good practice probably to check those wall warts. Couple things I wanted to highlight. I guess this is the manual that came with it. It was obviously printed out, not factory, I'm sure, this way, but it can test TTL and CMOS logic chips, just like the TL866 parallel port. It does perform device insertion tests, so if you put in a chip backwards or something. It also has a contact check, just like the Advent, which I like, where if it's making poor contact with the chip socket, it's going to tell you that there's continuity issues. It has a current limit protection, and it also performs self-test, which I already mentioned. It also says here that it programs the programming verification at marginal supply voltage, which is what you're supposed to do with these programmers. Is it's supposed to program it, and you're supposed to verify it technically, I think, at at the 0.5 volts higher than 5 volts and down to 4.5 volts to make sure that the chip can read the data at both low voltage and a slight over voltage scenario. So you're supposed to do that. Let me see if there's anything else that I wanted to cover. I don't think so. But yeah, I'm excited about this because it does bipolar proms. I mean, this is like, and the software is nice, but it is an old parallel, cable programmer, and it works on Windows XP or Windows 95 and stuff, so it is a little bit older, but it does do microcontrollers. Let's see here. This is what's really interesting. It does Harris, Philips Signetics, NS, TI, and Tesla. Does all of those for proms. It does the Tesla proms, which I acquired some, so that's kind of cool. And they're like oddball proms. And then it does, those are all the bipolar proms, and it'll do all the EPROMs, 8-bit, 16-bit, from, with 1702s and 2708s. Has an asterisk by that. You need an additional module, it says, to program those 1702s and 2708s. I've never had a need to do that. I think I do have some 2708s boards, but I've never had to program them. It does have low voltage support up to 1.8 volts. TTL driver provides pull up, pull down, tri-state to all 48 pins, so you can read any of the 48 pins, and so it makes it so you don't actually have to have adapters and stuff like that for most anything that's a dip. And then it shows you what TTLs it reads. It does do some static RAM tests. That's just like the TL866 though, but obviously this can program the higher voltage stuff. Standard options, insertion test, contact check, ID byte check, illegal bit test. You can also, I think, customize some of the tests too for like the TTL stuff. You can do your own stuff. I don't know. I haven't read into that too much. I do have the right power supply. It says 12 volts, 1 amp, 12 volts AC or 15 volts, or 12 to 15 volts AC. Max 1 amp power. So yeah, anyway, okay, so that's that. I'm going to power it up and do a self-test on it here next. Alright, here we are at my little programming area station, I guess, if you will. But obviously I have a bit of a problem or addiction to programmers, I guess. I'm just interested in learning about each one of them and finding. So this is my last EMP30 that I have. I'm going to probably be selling that soon. And then I have my Pilot MVP over here, which I had another Advent, the U84, which I sold. Unfortunately, the guy, I think eventually the guy I sold it to said that the power supply eventually went out again, unfortunately. But I had picked up this Advent MVP, which is a 40 pin, and I did a video on that, I think. And now I have this BK Precision Pro 864. The new ones are USB based, but they cost a lot. They cost like $1,000 and stuff. This one, I saw one on eBay go for, I tried to get cheaper. I was getting greedy. I tried to get one for around like $80, and I think he eventually sold it for $95 or something. But it didn't come with the power supply or parallel cable and stuff. And this one was over $200 actually. But I just wanted it. You know what I mean? I wouldn't have paid that much normally for it, but since I've been selling some of the programmers, I could justify it to myself somewhat. But anyway, I gotta get a parallel cable. I'm gonna use the one from my Advent, and I'll power this up and be right back. Alright, I was reading the manual, and I haven't powered it on yet. I don't even know. I bought this off of eBay. I have no idea if it works or not. The condition that it's in, I would assume that it does, though. When you first power it up, supposedly these lights are supposed to come in and like do some blinking or something, like some type of self-check. So we are going to see what we get here. Yep, that looked good. And I don't think it turned, there's no power switch on this, so it's kind of like the EMP30. It only turns on once you click on the software. And let me pause and come back to this. Well, I'm going to get the software on first, and then I'll come back and show the software. Alright, I actually didn't have the software installed on this. It says it's running. Hopefully you can see this. Let's see. Yeah, I think so. But it says, this is the first time I'm doing it here. So program at 864. We're on LPT1. And let's connect. Uh-oh. First problem. It's 864. It's automatic. I got my power on. I have a little power light. Let's see, do I have my... I don't have my parallel cable plugged in. Be right back. Alright, so yeah, I had the other parallel cable in for the EMP30, so we're going to go LPT1 378. I know that's right. It says this version of the software is more than 6 months old. And this is version, I think I said this, 2.21, which is in 2005. I have to double check to see if that's the latest. I can't remember where I even grabbed that from. Okay. Sure. We'll associate that. Make it a little bit bigger. Okay, so what's it say here? Well, I have an AMD processor, that's right. It tells me my memory and all that. That's good. Establishing connection, PS2 high-speed mode. There's my device. There's my serial number of my device programmer. Cool. I've never used this software before. Programmer. We have a self-test option. Self-test. So I think I want to put in my self-test thing here. Put that into the programmer, I believe. And let's hit self-test. Oh, during self-test, the ZIF socket of the programmer must be empty. So this must be self-test plus, must be the other self-test. Communication test, RAM test, EPROM test, supplies and DAC test, pin drivers, analog, self-test successful. Alright, let's do programmer self-test plus. Procedure must insert the ZIF diagnostic pod. That's what we're going to do. In the diagnostic pod. Alright, so it looks like it's testing the same stuff. Self-test successful. Probably putting voltage on each pin and stuff, and there's some resistors on that thing. I don't know exactly what it's doing, but it's probably, you know, checking the voltage through the pins, I'm assuming. But everything is good, so that's awesome. I'm going to pause here until I have a chip to program, or maybe we'll just click around a little bit. Select EEPROM flash device. Wow, man, they really went overboard. I mean, they have, you know, definitely telling you what's going on as far as everything you click on. Okay, I don't know what I'm doing. Select device. Select EEPROM flash device. Alright, I'm a bit of a idiot here. That's select EEPROM or flash device by ID, so it's applying voltage. We just need to choose select device. And one of the things that I always like about the GQ4X is you can just type in 2716 and start to see all the 2716s that it supports, like the different Hitachis. See, I mean, this already, I like this. It's got, you know, Fujitsu, Fairchild, Intel. You got the Intel M2716 versus the regular 2716. I don't think there's any difference. And when we select it, does it tell us, what's it tell us? Does it tell us the voltage or anything? It does not tell us the voltage, which is unfortunate. Maybe I can change the log level. Log file. No, errors. It'd be nice if it gave us the option to, I might come back to that. Oh, check the device info. Alright, tells us what kind of chip it is. Package details. Part number description. M stands for military. Did not know that. I is industrial. Huh. Speed 150 milliseconds. I'm surprised it doesn't tell us the voltage unless I missed it. Tells you it's supported by the programmers. Blank check is performed at VCC minimum if verify option and device operation is set to twice. In the other case, blank check is performed at VCC nominal. Interesting. I'm gonna have to read up on this a little bit more. Alright, I'm gonna pause real quick. Well, I had the need to test a chip that I had pulled out of a Galaxian that I'm testing. It's a 74LS86. It's a TTL chip. So come up here, you guys can see this device IC test 74 TTL. Okay, we can just put 7486. It's pretty easy to find. I don't know what single step mode is, but if I do loop testing, it'll just repeat the test over and over and over again, which is kind of cool. And you can see that there. It's just testing away. And then I hit escape key and it, you know, basically passed the test 88 times. So that is testing a TTL chip. Alright, hopefully I can hold this stable enough. I have a need to burn. I was actually testing some Tesla chips here, and I can blank check them fine, but I don't have a need for these right now. But I do have a need for select device. And the cool thing here is you can actually check what type of device you want to restrict your search to. So I want to look for proms, and if I type in Tesla, it'll bring up the Tesla ones. If I bring up, AMD, if I just type in 82S123, we can find that right there. Double click it, and I'll be right back. I have to actually get the code ready. Alright, let's see here. File, load. We want to go to desktop somewhere. Galaxian. This bipolar prom there. I'm doing this for the first time, so wait, how do I buffer view? Never even viewed the buffer before. Alright, that's what it looks like right there. Looks good. This program. It tells us our options, what the device start address is. Insertion test is enabled. Blank check, we already blank checked it. Verify. When it says verify twice, it'll verify at 2 different voltages, obviously. Nice. Programmed 82. Programmed the bipolar prom, which is nice. Alright, I'm going to wrap up this video, but there was a couple things that I found pretty interesting. One was if you view and edit the buffer, you can do a checksum. And, well, this is all zeros, obviously, but calculate, and it gives you the different checksums and even an MD5 hash. So actually, let me load a file real quick that I was messing with. Buffer checksum, calculate, and then you get the, I don't even know what all of these are, but you get different forms of checksums like CRC, CRC-X modem, MD5 hash, etc. Actually, maybe if I go to, this is the same file on, oh, you can't really see it, on ROM ident, and you can see CRC32B is C3AC. Let's see what that is. C3AC. That's not one of them. CRC32 129 something. Nope. MD5 checksum. Oh, ROM ident doesn't give you that. Fluke signature is C471. Is that one of the ones? Nope. Well, you get your 0952, which is the regular checksum. So I thought it was kind of interesting. I was hoping that maybe it would be more beneficial. But it doesn't look like it's that beneficial, I guess. But anyway, it gives you different checksums. What else did I want to show real quick? I wanted to test a few chips. So this is I think I had one that was wrong, bad, but anyway, this is, if you can see it, 74LS151. So we're going to go, I know we already did a device check, but we're going to go to an IC test, select 74TTL, and 151. It basically gave me an error that it can't find the programmer. So sometimes you have to, if the programmer, my computer went to sleep, you can hit refine programmer, and then device, IC test, 151. Okay, so this is what I wanted to show. So the looping test I showed already, which is kind of cool, but let's do step-by-step mode, which I thought was pretty interesting. This is definitely above and beyond what the TL866 does. Alright. So hopefully you can see this, yeah. So it's basically saying, do you want to go, you have to hit yes for each time it's going through. So it's saying application ground at pin number 8. Yes, we want to apply ground to pin number 8 because that's right. Apply 5 volts to pin 16. Yes, that's correct. And now it's going to say do the logic. So it's going to say I'm going to make the logic level at pin 1 low, and high at pin 2, low at pin 3, high, etc. It's basically going through and doing all the logic that it's applying to the TTL chip, which I thought was pretty cool. And now it's reading the outputs. So this could be useful, like if you don't want to look up like the chip, or you're about to program or put a chip in your logic comparator. I know now that pin 5, right, is an output, because it says reading low level from pin 5. That's one of the outputs. Reading high level from pin 6. That's another output. And then it goes through another application. So I guess there's only 2 outputs on pin 5 and 6 for a 151. And then it goes through the logic again, applying different logic levels for the inputs, and then tells you it's reading what it's reading on the outputs. I just thought this was pretty cool. You know what I mean? To do that. So, and then you can also do the loop test, obviously. All right, so that's one thing I wanted to show. And what was the other thing I wanted to show? We did the self-test. There's this device list cross-reference that you can generate, and it actually creates a file, a HTML file, that will tell you what programmers and program what manufacturers. So for instance, I'll choose one that I know doesn't have a lot of chips, like Harris or something. Where's Harris at? That are supported at least by this programmer. And it basically shows you that the 864 supports HM6514, 6516, blah, blah, blah. And you can go back if you're curious about what chips it supports and stuff. Like maybe, let's look at Signetics real quick for bipolar proms. And it'll show you which ones need adapters with the 864, which is what I have, and which ones it programs, etc. Where's my bipolar proms? Signetics devices. Philips Signetics, right? Is that what I clicked on? Oh, there. I must have clicked on the wrong one. There you go. 82S123s, etc. Okay, so that was pretty cool that it generates that file on its own, that cross-reference list. Let's see if there's another interesting thing. I think that's pretty much it. I mean, it doesn't give you, what the voltages are. I can't find that anyway, what information about that. This is, but it does give you good amount of detail about the part numbers, and it will say what programming algorithm it's using too. So it says algorithm name bipolar prom. That's the algorithm it's using for the 82S123. If I go to device, select, let's look at a EEPROM. Let's do a 27 16B. Oh, actually it does. Here we go. Well, the generic, it's telling you what the voltages are from the generic standpoint. A 2716B is 12.5 volts. And then I guess this is telling you what programming algorithm it's using. This is going to use the Intel programming algorithm. Oh, that's pretty interesting. I didn't catch that before. So let me do, instead of 2716, let's do 2532. Let's go to HN462532 Hitachi chip. Hit OK. If I go to the device info, it says it's using the standard programming algorithm, which is 50 milliseconds, I think, pulses, or 50 microseconds. I'm not sure. Probably microseconds, I think. I'd have to go back. I should know that. Anyway, this is my new programmer. I'm super excited about it. Yes, it is basically, because it can do TTLs and all proms, not all proms, but a lot of bipolar proms, almost all of the EEPROM needs, 48 pins, PALs, GALs. The only downside, it is a parallel port. I think I'm going to be able to get it working on a Windows 7 machine that I have that has a parallel port. Hopefully that's the case. But it's really the first time I found a programmer that can do everything the TL866 TL866 does for me, as well as all my arcade needs and like the TTL chips, and it does test some memories too. I just think it's so far the best of all of them, and I like the software. I wish it gave me a little bit more information about the programming voltages, or allowed me to choose different programming voltages. But I'll come back if I discover that it can do that. Otherwise, the Advent, I like that too. It does, I like the fact it has self chip continuity checks and wrong insertion checks and stuff like that. And it's quiet. There's no fan. Does have an external power supply. That's the only downside, I guess. It's got a wall wart kind of thing, whereas the Advent has built-in power supply. But because there's no adapters and everything, these are definitely my two favorite ones. There's one of these Advents on eBay right now for $150, and again, I paid definitely more than that for this 864. But if you get lucky, maybe you can find an 864 or something like that for $100 or so. If you do, get it, because I think it's cool. I think it's probably one of the better ones that I've found so far. So, all right, guys, that's it for this video. Until next time, my addiction to EEPROM burners, I think, is almost over, though. I think this is going to be it as far as EEPROM. Maybe, do I really want to get a data I/O? I don't think so. I think I'm going to live with this small thing, and it'll do everything I need for the most part. So, all right, guys, cheers. Bye.